We want to find the equation of the plane with the normal vector 3, 4, -2 that contains the point 1, -3, 5. So what is a normal vector? What does that represent? That is a vector that is perpendicular to every vector in the plane. The piece of paper that is sitting right here would have this as the normal vector, standing straight up directly in the z direction. Notice this would be orthogonal to any vector that I could draw in the plane. And we would see that this would be orthogonal to this vector, be orthogonal to this vector. Any vector I would draw, this vector 0, 0, 1 in the z direction would be orthogonal or perpendicular to it. So what the normal vector does is it tells us what the tiltiness is of the plane that we're working with. It's analogous to the slope, if you will. So let's take a look at this plane. So you'll notice the n vector is normal to this plane that contains the points q, s, and r. And that normal vector is perpendicular to vector qs, perpendicular to qr, perpendicular to any vector that is in that plane. And again, that tells us how tilty it is, but that's not enough. It's just like the slope is not enough to give us a line. We need a slope and a point. I need a normal vector and a point to be able to do this. So what we have here is we have a normal vector 3, 4, -2, and the point 1, -3, 5. So getting the equation to this is actually relatively easy because the 3, 4, -2 are going to be the coefficients of the equation of the plane. So the equation of the plane is 3x plus 4y minus 2z. Notice that's the coefficients of the normal vector. We haven't used the point that we were given. The point that we're given here is 1, -3, 5. That fixes its location in space. So if I plug a 1 in for x, plug in a -3 for y, plug in a 5 for z, what do I get? That will give me the number that goes on the right-hand side. 3 plus 4 times -3, -12, minus 10. What does that give us? 3 plus -12, -9, minus 10 would be equal to -19. So that would be the equation of our plane. So looking at this plane, you'll notice it has 3 points, Q, S, and R. 3 non-collinear points uniquely determine a plane. So how can we find the equation of the tangent plane if we're given 3 points? What are we going to need to do? What's our process? The goal is for this normal vector to be orthogonal to both of them. And how do I find a vector orthogonal to 2 given vectors? What's my strategy there? Orthogonal vector to 2 given vectors, that of course is a cross product. So I'm going to need to determine what 2 vectors are in the plane and then take their cross product to find the normal vector of that plane. So let's take a look at an example. So we want to find the equation of this plane that contains these 3 points, Q, S, and R. And again, I've got to construct 2 vectors and then take their cross product to find the normal vector to the plane. So I'm going to find vector QS starting at Q, ending at S. What's my change in X? From 1 to -4 is down 5. From 3 to 3 is 0. And from 2 to 0 is down 2. Now, I certainly could do QR, I could do SR, I could do RS, I could do RQ. I have many choices here. I'm going to choose to do QR to get the second vector. I'll put a little hat on it to emphasize that it's a vector. From Q to R, from 1 to 0 is down 1. From 3 to -3 is down 6. From 2 to -2 is down 4. So I have vector QS and vector QR, and I want to find the normal vector to that plane. So that normal vector simply will be the cross product of QS with QR. So let's set that up. It's our usual strategy for a cross product. IJK across the top. And then negative 5, 0, negative 2 here. Negative 1, negative 6, negative 4 here. And let's remember that it goes plus, minus, plus across the top. Plus, minus, plus. So it's plus I times his minor, minus j times his minor, plus k times his minor. So what will that give us? Plus I times his minor, minus j times his minor, plus k times his minor. So what is our strategy? We cross out the row that I is in and the column that I is in, and we get 0, negative 2, negative 6, negative 4. With the j, cross out the row that j is in, the column that j is in, negative 5, negative 2, negative 1, negative 4. Cross out the row that k is in, the column that k is in, negative 5, 0, negative 1, negative 6. Then we're going to evaluate these determinants. So what will that give me? We get n equals. In the I direction, we get 0, minus 12. Minus, in the j direction, we get 20 minus 2. In the k direction, we get 30 minus 0. So where does that put us? So we get n equals negative 12i minus j times 18, so it'd be minus 18j plus 30k. So my normal vector is negative 12, negative 18, 30. Negative 12, negative 18, 30. Now, what do we need to think about this? That any multiple of this would also be orthogonal. So if this is my vector here, the z vector, maybe this is 6 times z. If it's 1/6 this big, it is still a normal vector. So you'll notice that all of these things have a factor of 6. So if I divide by negative 6, or take the fact that my new n is going to be negative 1/6 times the old n, we're just shrinking it down to size a little bit. Negative 1/6 of negative 12 is 2. Negative 18 divided by negative 6 is 3. And 30 times negative 1/6 would be negative 5. So that's what I have as my normal vector. Now, we also needed to have points. So my equation is going to be 2x plus 3y minus 5z equals something. So do we recall the points that we had when we began this process? What were they? Well, we had 1, 3, 2, negative 4, 3, 0, 0, negative 3, negative 2. I can use any of them. I'm going to choose to use the q of 1, 3, 2 to find out the number that's on the right-hand side. So I'm going to plug 1 in for x, 3 in for y, and 2 in for z. So if I have 1, 3, 2, 1 goes here, 3 goes here, 2 goes here. But this should be the same for all of them. What do we get? 2 times 1 is 2, plus 3 times 3 is 9, minus 5 times 2 is 10. 11 minus 10 is 1. The number that goes on the right-hand side should indeed be 1. So the equation of my plane is that. The equation of the plane would be 2x plus 3y minus z equals 1. The equation of the plane is 2x plus 3y minus 5z equals 1.